Hey everybody. All right, so this one we're going to do a little review on decimal division. Okay, decimal division, just like multiplication, requires us to be masters of division. Now here's just a division principle. A divided by B is the same as A divided by B, which is the same as A divided by B. This is the weird one. This is the weird one because it does not read left to right or up and down like we're normally used to reading. So we have to remember, if that's how it's given, that A flips around and goes underneath the little house thing or whatever, underneath the sign, okay? So with that in mind, let's try a question here. Suppose we had the question 15 divided by 4. So the first thing that I'm thinking about is this. 15 divided by 4 is the same as 15 divided by 4 is the same as 15 divided by 4. Aha! That's what I'm dealing with. I am not dealing with this. This guy? Wrong. Why? Because the numbers are flipped around. So the very first thing we do in division, let alone decimal division, is go through this process. 15 divided by 4 equals this, where the 15 goes tick, tick, tick. It's always like the blue tip, okay? That's where we start from. And then what do? Well, what we're doing here is replacing, obviously you did not see a decimal here, right? So we're just going to show you how a remainder can become a decimal. So then you take your 4 and your 15, right? So here we go. 4 fits into 15 3 times. 3 times 4 is 12. La-di-da, that's 3. Normally we would say the answer is 3 and 3 extra pieces out of 4. That's back in the day. Now we are going to show you the decimal equivalent. 4 goes into 15 3 times. 3 times 4 makes 12, subtract 3. Instead of stopping, we are going to add up to 4 zeros for our class. Truly, these zeros go on forever and ever to the edge of the universe. But for us, we'll only go to 4 spotting. Otherwise, it's just too much work. Okay, so instead of just stopping here at the remainder, I bring down the 0. And I'm kind of ignoring this green decimal right now. I'm just working with the digits. How many 4s fit into a 30? By now, we know that it's 7. 7 times 4 makes 28. Subtract 2. How many 4s fit in a 20? 5. 5 times 4 makes 20. Subtract 0. Bring down 0. 4 goes into 0. 0 times 4 is 0. And what actually we have here is a case of repeating zeros. If we kept going on and on and on, we'd see that it'd be more and more zeros here, right? Okay, so we can just stop because we already can predict the answer. Now over here, that decimal beside the 15 will go right above and go right there. So your answer is technically 3.75. Now, that should make no surprise to anybody because if you had 3 quarters in your pocket, you would have 75 cents, okay? So anyway, that's how you do it. Instead of just stopping here and having a whole number and a remainder out of this thing, now the green is the new stuff. You put your decimal, boom, 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 get some zeros back there, and then you run the same cycle. And that is how you get your decimal answers to start with. The next type of question will be actually involving real decimals. All right, so let's try this question here. 0.6 divided by 0.24. The first thing I'm thinking of is, hey, that looks like this. And hey, that looks like this. Remember, that's the very first thing, in accordance to this pattern up here, okay? 0.6, 0.6, 0.6. Okay, I'm going to start with this guy. The first thing you want to show on your page is the original question, always. 0.24 and 0.6. That's the first thing. All right, so we want to get rid of the decimal on this number. And we ask ourselves, wouldn't it be nice if we just had the number 24? If we had the number 24, there would be no decimals in play, but there would be an invisible decimal right here. And every number has an invisible decimal. That's why if something's $1 at the store, they can show you this instead of showing you this, right? There's an invisible .00. Every number in the universe has an invisible decimal at the end of it, plus and then a bunch of zeros following it. So what we're going to do is say we're going to get to 24. How on earth do you do that? Well, we would have to bounce the decimal twice, 1 spot, 2 spots. But the only way we can keep this statement true is if we also do that over there. So your very first couple lines are going to show your original question and then your bounces. You gotta show your bounces. When you show your bounces, you're showing your instructor that you know what's going on. That's what you do. Then you leave some space and then you draw the cleaned up version like this. 24, invisible decimal right there. And then we had a 6. But where did the decimal go? It went over here, and so there'd be an invisible 0 there. So technically we have 60 dot. So it used to be there, 1, 2. It used to be there, 1, 2. Great. So there's no decimals here, and that's where our decimal ends up lining up. Now, our decimal will go in the top part right there. Now we also can't forget, let's put a few zeros on the back of this guy, just like that. All right. And now we just do our math. 24 fits into 60. Well, we're going to have to maybe make a skip count chart on the side if we're not sure. There you go. That's the first couple there. 24 fits into 60 twice. It fits into 6 0 times. Fits into 60 twice. 2 times 24 is 48. Subtract 12. I'm going to write really small here. 24 fits into 120 5 times. I know that just from memorizing. And you will too soon enough. And then we see that we're going to have a bunch of zeros down here. So as soon as we see that, just stop. We don't need to keep going. And we see right away that our answer is actually 2.5. Can you believe it? The answer to this question, and this question is 2.5. I point that out because there's no way you can predict that by the digits alone. I know some people, they look at the 6 and the 2 and the 4 and they think the answer is going to be like 4.26. But when it comes to decimals, you got to throw out that ways of thinking. Don't think like that anymore. You actually have to go through the machine. All it is do your translate it to your long division and then show bounce, 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 bounce on both sides. The same amount of bounces. In this case, it happened to be 2. And then you pop your extra zeros down here, and you complete your long division machine. That's all it is. So 2.5 is your actual answer. Now, while we're at it here, I just had a thought. Check this out. There is a shortcut here. If you are good at, let's say, cutting numbers in half or something like that, I know that the answer to this is going to be the same as the answer to this. And the answer to this is going to be the same as the answer to this. So if you like using smaller numbers, think of cutting in half all your numbers. I cut that in half and cut that in half. Boom. Cut those both in half. There. Now watch what happens. 6 goes into 15 twice. That's off by heart. That's 12. 3 decimal 0. Bring down the 0. 6 goes into 35 times. 5 times 6 is 30. And that's the end of the road. So we see again 2.5. But the good thing is that we had smaller numbers to deal with than over here. Okay? We still get the same answer. So this is a fun little trick. It's not on the test. You don't need to know it, but it's nice and it can save you time when you're doing your homework. All right, so before we do another example, I'm going to show you this way of how to do it. Now, I love this way because if you can do it this way, then you can not only dominate decimals, you can also dominate fractions. Here's how it works. You look at the decimals, 0.6 and 0.24. Maybe it would be valuable if we had them lined up. Keep that in mind. Okay, so it's 0.60 and 0.24. The question is, what do I need to times this by to get rid of the decimal so that I would only have 60 and 24? Well, if I have 60 and 24, that means the decimal's over here. And if the decimal's over there, it means it must have bounced twice. 1, 2, arrow tip dot. 1, 2, arrow tip dot. Well, how do you move a decimal 2 spots? And the answer is you times it by 100. Both top and bottom number get times by 100. Why? Because 100 over 100 equals 1. So if I have something and I times it by 1, I get a new version of the same value. That's all it is. Okay, so I took this thing. I needed to bounce the decimal 2 spots, so there's 2 zeros on 100. There's our 2 spots. If I times it by 10, it would only bounce there 1 spot. But these have to be the same numbers. It's got to be 10 over 10, or 100 over 100, or 1,000 over 1,000, all depending on how many spots you need to bounce it. And then I'm going to just show it cleaned up over here. And then after you're here, you do long division as normal. Or you just simplify the fraction. Okay, so earlier we did long division as normal for this. So at this point, we're going to just treat it as a fraction to simplify. And what do you learn from your previous unit? How do we simplify this thing? You take factor trees. 6 times 10, that's 2 times 3, that's 2 times 5. There we go. Circle your prime numbers. You're allowed to look at your prime number card on our exams. That's 3 times 8, and 8 is 2 times 2 times 2. Okay. If you're not sure about these guys, there's lots of videos about these. These are called factor trees. So I take 60 over 24, and I say 60 is 2, 2, 3, 5. 2, 2, 3, 5. 24 is 2, 2, 2, 3. 2, 2, 2, 3. And then lucky for us, a lot of these things will cancel out. Those go away, those go away. The 3 cancels the 3. All I'm left with is the 5 over the 2. Now, I take that over to my thought cloud over here, and I can easily do long division with this one. And I can see right away. This is 2 1/2. Or if I was to continue this, it would be 2.5. Okay, so if your teacher wants a fraction answer, you give them a fraction answer. If they want a decimal answer, you give them a decimal answer.